Duisburg, Germany, 14th of October, 1944. Air raid sirens wailed as bombers crossed the Rhine in clear daylight. Below, Duisburg's marshalling yard, rail hub where freight cars were sorted, and the inland port anchored the Ruhr, Germany's main industrial basin, and fed coal, steel, and troop trains. Operation Hurricane, RAF's mass raids on 14-15 October 1944, would test whether smashing one hub could cripple a nation's rails. By late 1944, the German rail system looked dense on maps, but it lived through a few choke points. Yards, bridges, and junctions bore most traffic. Redundancy was thin, and fuel and locomotive shortages turned damage into paralysis. More than 1,000 bombers hit Duisburg within hours, blasting tracks, signals, and repair sheds, and scattering thousands of wagons across miles of tangled steel. This is the setup for a wider collapse. One day in the Ruhr revealed the network's weak points, and why, that autumn, the rails began to fail. Dawn broke over Duisburg with coal wagons already rolling. On the WWII hump, a raised sorting hill using gravity to classify cars, brakemen watched wagons crest and drift into the fan of tracks below. A few hundred meters away, barges nosed into quays at Duisburg-Ruhrort-Hafen, Europe's largest inland port by throughput. If this choreography faltered, furnaces cooled and locomotives missed their paths. This city sat where the Ruhr met the Rhine, and its rails mirrored that confluence. East-west trunk lines fed the Ruhr's mines and mills. North-south feeders hugged the river and linked to barge traffic. The marshalling yard, rail facility where freight cars were sorted, tied these flows together into timed blocks. Coal loaded at dawn could be in a coking plant by midday, then back as fuel for boilers by night. WWII's design amplified both speed and fragility. A hump yard let gravity do most of the work, but it depended on intact ladders, series of turnouts linking parallel yard tracks, guided by signal boxes. Interlocking safety system that prevents conflicting movements through switches governed every route. If one ladder jammed, an entire classification group froze. The quays at Ruhrort ran almost into the yard itself. Sidings paralleled the river wall so cranes could swing coal, ore, and finished steel straight into wagons. Transfer times were short, and so were the buffers. In 1944, the Reichsbahn, the German National Railway, relied on rapid wagon turnaround to offset equipment shortages. Coal drove nearly everything. It fired locomotives and kept blast furnaces, power stations, and coking plants alive. Delays did not just make schedules messy. They stranded fuel on the wrong side of the river or the wrong side of a junction. One missed classification cycle cascaded into idle shifts and cold engines. Signal boxes perched over this geometry like air traffic control. Operators read train orders over telegraph lines and drove switch motors from a central frame. Those electrical feeds and wires ran exposed along embankments and fence lines. A single break could black out a throat where hundreds of wagons should have moved each hour. By mid-1944, the system had little slack. Spare rails and switch motors were scarce across the Ruhr, and crews had thinned under repeated call-ups. Locomotive maintenance lagged, pushing more trains onto fewer serviceable engines. The Reichsbahn compensated by compressing work. Shorter layovers, tighter connections, faster reclassification. Short-haul coal shuttles lived on these rhythms. Trains of empties arrived at WWII, took the hump, and departed in new blocks every few hours. That tempo conserved locomotive hours, the basic currency of a strained network. Without WWII's constant sorting, coal would sit in the wrong wagons on the wrong lines. Aerial photographs told an outsider's version of the same story. Reconnaissance planes captured dense track fans. Dozens of nearly parallel lines splayed like combs that signaled a hump yard's heart. Such patterns were ideal for area bombing. Even near misses tore up multiple tracks and crippled ladders. Yard geometry concentrated the most critical assets within a few square kilometers. The river-rail interlock made Duisburg a single point of failure for multiple flows. Barges fed sidings, sidings fed main lines fed plants that made coke, steel, and munitions. If the port worked but the yard did not, quays jammed with barges waiting to unload. If the yard worked but a bridge failed, wagons filled faster than any trunk line could clear. Civil defense tried to hide the target. Smoke generators belched screens over the river and parts of the yard, but the expanse was too large. Signals needed to be seen, and crews needed to move. Concealment came in strips and patches, not a blanket. Repair capability existed but was local and thin. A Hilfszug, emergency railway repair train, sat ready with rails, tools, and a crew, but it could not conjure switch motors or telegraph cable that depots no longer had. It also could not be in two places at once. When more than one ladder failed, triage replaced routine. Even when the rails were intact, power and communications remained a single thread. Interlocking machines needed electricity. Telephones carried clearances and priority changes. Exposed feeders along the yard perimeter made soft targets. A cut wire turned the most complex yard into a collection of inert tracks. The Duisburg node did more than sort wagons. It synchronized clocks across an industrial basin. East-west traffic had to meet north-south windows at the river. Every hour added to a detour burned coal and crew time that no one had to spare. One yard stoppage forced reroutings that lengthened trips and consumed the very locomotive hours the system lacked. By late summer, coal trains already queued for classification. Schedules were tight, and engines overdue for heavy work stayed on the road. Maintenance shops deferred tasks to keep steel moving and troop transports on time. The margin that made this possible sat on the WWII hump. Reconnaissance crews understood what they were seeing. Density meant importance, and importance meant vulnerability. The tracks that made Duisburg fast also made it brittle. The only question was how many blows it would take to stop it. Maps glowed under shaded lamps in a cold briefing room. Crews traced red lines toward Duisburg and circled the sprawl of rails and water the Ruhr lived on. If their bombs broke the sorting heart of that sprawl, factories and troop trains would slow within hours. This plan promised not just destruction, but a demonstration. Operation Hurricane was built to show overwhelming air power within a single day. Bomber Command, the Royal Air Force's heavy bomber force, would lead, with Air Chief Marshal Sir Arthur Harris intent on crushing the transport nodes that kept the Ruhr supplied. Target sets focused on marshalling yards, track junctions, and the inland port at Duisburg. Bridges stayed off the list unless specified. Planners wanted detour options preserved for Allied use later. Daylight gave an edge on narrow, linear targets. Rails ran in straight, measurable lines. Daylight let crews hold a steady axis along a yard and keep patterns tight. Forecasts promised enough clear breaks for visual marking despite expected smoke screens. H2S, a ground mapping radar used to locate urban and industrial areas, would get formations to the city. OBO, a radio navigation aid using precise transponder ranging, would steer the first marker aircraft onto an exact point. Number 8 Group Pathfinders, an elite target marking force, would open the attack. Their job was simple to describe and hard to execute. Paint the yard's ladders and the port basins with colored indicators that the main force could bomb through smoke and blast dust. Photographic reconnaissance had already mapped switch fields, signal cabins, and distinctive track fans to create unmistakable aiming references. Briefings highlighted the Wedau and Hochfeld-Sud classification fans and the sidings along Ruhrort's keys. Bomb loads matched the geometry below. Crews carried mixes of 501, 000-pound general-purpose bombs to crater track and spray fragmentation through signal boxes, relay huts, and repair sheds. Cookies, thin-cased 4,000-pound high-capacity blast bombs, would shatter walls, blow out roofs, and collapse steel frames over ladders that controlled dozens of parallel tracks. Incendiaries rode along to ignite timber sleepers, wooden sheds, and cable ducts that snakes of wiring depended on. Run-in routes were drawn to minimize flak exposure while keeping a steady bombing axis along the yard. The aim was to enter on a line that matched the yard's length, release quickly, and exit before defenses settled on a single altitude and speed. The method relied on a massed stream of aircraft to saturate guns and compress bombing time. Planners expected concentrated pattern bombing to overwhelm yard geometry in minutes, faster than any local defense or repair gang could respond. Markers rehearsed the choreography over English airfields. Ground crews laid out scaled rails and yard shapes with lime and canvas, and pilots practiced run-ins at the planned headings and altitudes. They drilled timing between oboe cues and flare drops, then between the first marks and the follow-up backs up that corrected drift. The point was rhythm, a sequence tight enough that the main force would find a corridor of color and smoke sitting over the correct ladders. Timing mattered as much as accuracy. The main force was scheduled over Duisburg in the late morning of the 14th of October, 1944, when sun angles favored contrast on rails and water. The night attack that followed would deny repair crews a full shift of daylight to reconnect ladders, re-string cable, and clear wreckage. Oboe-led mosquitoes were to light the first marks. H2S-equipped heavies would use those cues if the smoke thickened. Crews were cautioned again. Do not strike bridges not on the target list. Aerial mining of river approaches would be left to separate operations to avoid redundancy and keep navigation predictable. The logic leaned on 3 pillars: concentration, repetition, and node selection. Concentration put hundreds of bombs into a few square kilometers of the most critical track. Repetition hit the same node twice within hours, turning superficial damage into functional ruin. Node selection exploited the way yards multiplied effects. A single shattered ladder could stop dozens of classifications, and a burned cable run could black out an entire throat. The stakes extended beyond Duisburg. Yards were time machines for railways. They converted arrivals into timed blocks that fit the main line's capacity. If WWII and Hochfeld-Süd stopped classifying, empty coal wagons missed mine loading windows, full wagons missed furnace slots, and locomotives idled in the wrong places. By design, this plan pressed on that single weak seam. Deny the sort, and the Ruhr jammed itself. Air raid sirens rose as the first marker aircraft crossed the Rhine under broken cloud. Flak rings around the port, and the southern approaches opened at once, throwing black bursts into the gaps. What followed would turn Duisburg's sorting heart into dead track and show why the network would buckle within days. Pathfinders ran straight through the smoke and dropped target indicators, colored flare marks used to aim bombs, along the main classification ladders and the sidings beside the quays. The lights pulsed through gray and white screens pushed by smoke generators over the WWII fan and the riverfront. The markers burned in lines, not dots, laying bright axes over the switch fields and the portrayal throats. Batteries kept firing, but the marks stayed visible long enough. The first heavy bombers steadied on that color and released in dense patterns. Cookies landed first. Their blast pancaked signal boxes, sheds, and the lightweight buildings that held relays and telephones. Roof trusses lifted and folded. Brickwork fell into stairwells and blocked doors. General-purpose bombs followed, cratering approach tracks, kinking rails, and burying sleepers under ballast and clay. Fragmentation ripped through point motors, electric switch machines that moved turnouts, and ate into signal wiring and telegraph lines that ran along the yard edge. Interlockings failed as cable trunks burned. Signals froze to danger and stayed there. One signalman kicked a door and dropped from a side ladder as glass and timber blew inward around him. He hit ballast, rolled, and ran through settled dust toward the embankment. Above, his box stood open to the sky, levers trapped under fallen beams. The levers meant nothing without power or wires. Fires spread along timber platforms, and the timber lined cable ducts that stitched the yard together. The ducts acted like chimneys. Fire walked under the ballast and popped up at switch cabins and hut clusters. Shrapnel cut brake hoses on standing wagons. Some rolled uncontrolled until rails ended at crater lips or bent into new curves. They slewed into buffers and heaps of scrap and stopped. Others sat canted over, axle boxes smoking, air gone and handbrakes useless. Port cranes lost power as feeders tripped and substations took hits. Quayside rails buckled where heat bit into the chairs and fish plates, trapping loaded wagons at the water's edge. A direct hit collapsed a yard footbridge and dropped its girders in a crosshatch over the classification tracks. The steel snagged couplers and brake gear on wagons that had not moved, turning intact tracks into blocked ones. Crane jibs froze mid-swing over barges, their motors dead and hoists pinned. Secondary explosions walked through the storage areas. Drums of fuel and lubricants burst and sent sheets of flame across cobbles and timber floors in stores and workshops. The inland port basin filled with smoke until fire crews could not see 10 meters. Sirens on their engines wailed without direction. Follow-on waves, tightened patterns and overlapped craters across the switch fields that pathfinders had marked. Where one hole had been, three now met and undermined embankments. Downriver, barges rode at idle, tied into blackened bollards. Mooring lines smoked under embers that fell out of the plume and settled on canvas covers. Boatmen slid hoses off decks and held them over wet planks while they watched cranes hang like dead insects over the quay. The smoke lay on the basin and backflowed into the rail approaches. The stream kept its timing. Air defenses remained active, but they could not spread the bombers or drive them high enough to spoil the patterns. Guns tracked and fired, some training to new headings as the runs shifted. Gaps opened, then closed under more aircraft. Locomotives in steam stood with fires banked or drawn, crews gone to shelter. They left them to avoid boiler explosions from nearby structure fires that could flood hot fireboxes with water when pipes burst. Water mains ruptured under shock. Hydrants failed as pressure collapsed, and hoses lay useless across ballast and splintered sleepers. Firefighters tried relays from the basin, then backed off under falling debris. A crew from a Hilfszug arrived, surveyed a switch field, and opened notebooks to sketch damage. They withdrew minutes later as unexploded ordnance was reported between the ladders and the down main. On the western edge, a rake of empties had snapped couplings and folded like a paper fan. In the center, a turntable pit filled with mangled planks and twisted tie bars from nearby points. Along the river throat, the track geometry was readable only as patterns of shattered timber and black earth. The last bombers turned west, leaving upright columns of smoke that marked each yard complex. Wedau, Hochfeld sued, and the lines to the quays. By early afternoon, the marshalling yard surface was a pitted field of craters, debris, and water in bomb holes. Every ladder had gaps. Some were gone for tens of meters, others hung by a single intact switch, and a few rails that led nowhere. The port rail interface was severed. No safe track led to an intact quay or an undamaged shed where a crane still moved. Signals still showed red. That did not matter, there was no path to clear. Telegraph poles leaned at angles, some with crossarms gone, others blackened to a shine. Relay huts steamed and hissed as water met hot metal. A few sparked in intermittent arcs. In places the ballast looked like beach shingle, scoured and heaped, with the timber ends charred flat. Survey teams reapproached when the explosion stopped, then pulled back again as fuses ticked and whistles warned of gas. They marked the ends of intact rails with white paint and chalk, and they stopped counting craters when totals no longer changed the result. Across the riverfront, wagons loaded with ore and coal sat stranded in ones and twos, isolated on scraps of line between two holes. The port had cargo and the river had boats, but the rails that tied them together were gone. The attack ended in minutes but took hours to settle into quiet. Smoke layers thinned, and shapes emerged as gray silhouettes against blackened ground. The yard made no sound beyond the soft hiss of steam and the pop of sap in timbers. What had been a machine of timing and gravity now consisted of disconnected parts. The damage did not just stop trains. It made sorting impossible. Without ladders, no block could be built. Without power or wires, no route could be set. That choice of target mattered more than tonnage dropped elsewhere. The network would feel it by the hour as empties missed mines, fulls missed furnaces, and engines waited on the wrong side of the Rhine. Classification stopped the moment the interlockings died. Signals froze and levers meant nothing without power or wires. Hand signaling was possible in a quiet yard. It was lethal in a cratered, burning one. Ladders lay cut in several places, so even intact approach lines had nowhere to send or receive wagons. The dispatch office tried to push detours while smoke still drifted over the diagrams. Telephones rang dead or returned busy tones as circuits overloaded. Telegraph loops that tied dispatchers to yardmasters fell silent when poles went down and repeaters lost power. Orders that did get through piled contradictions. Hold here, proceed at caution, expect obstruction. Locomotives needed turning, water, and coal to remain useful. Turntables jammed with debris and bent ring rails. A single broken tooth immobilized an entire table. Water towers leaked or stood cracked, and coaling stages, structures for loading coal into locomotives, had stairs blown out and chutes warped shut. Crews banked fires or let them die rather than risk boilers running dry and seizing. Repair units formed, but the first task was to make the ground safe. The Hilfszug stood ready, yet crews stepped into a field seeded with UXO unexploded ordnance, bombs that failed to detonate. The work sequence was methodical and slow. Mark and clear duds, drain and fill craters, lay sleepers, align rails, pack ballast, and test circuits. Every step stalled on missing parts, empty tool bins and heat that made metal unworkable. Temporary fixes did not scale to the damage. A track panel, pre-assembled rails and sleepers for quick laying, could bridge a single hole, but the ladders were whole mosaics of overlapping craters. Switch motors and point rods, linkages connecting switch units to rails, were specialty items. Local stocks in 1944 ran to a few spares. Signal cabins that burned took their wiring diagrams and relays with them. Without those, even intact frames could not be rewired quickly. Standing wagons blocked access to the worst breaks. Some sat locked behind fouled points and could not be moved. Others perched on damaged rails that might collapse under their weight. Yard cranes that could have cleared them lacked power or safe approaches, and road cranes could not reach across embankments while fires still flared. The workforce had thinned. Many trained men were on civil defense duty or already working fire lines. A repair gang stepped between sleepers with shovels and crowbars, then dropped flat as a delayed detonation lifted a shallow crater a few tracks away. Work suspended again while wardens listened for ticking fuses and marked fresh, no-go zones with paint and tape. Fire brigades still fought blind in pockets where smoke refused to clear, and port authorities restricted movement along the quays to keep crews out from under unstable crane structures. Access narrowed to a few paths that moved slower than walking pace. Trains stacked up on the approaches within the hour. Freight stood nose to tail from Oberhausen toward Mulheim, and relief crews could not reach them through blocked roads. Crews ran out of hours sitting at signals. They secured their trains where they stood and stepped off, as rules demanded. Each parked train consumed a block section. The line's capacity collapsed before a wheel moved again. Dispatchers issued slow orders, temporary speed restrictions, over routes with suspected damage, and then broadened them to whole districts when reports fell apart. A line that carried 30 trains in a day now carried half that at reduced speed. With Duisburg closed, empties missed mine windows and fulls missed furnace slots. The effective currency of the network, locomotive hours, burned away doing nothing. Detours were possible on paper and scarce in practice. And Oberhausen-Osterfeld handled classification for the Ruhr's northern arc. Both were already near saturation and had their own bomb damage to mend. Hamm could absorb some traffic, but distance and routing multiplied delays and tied up engines far from their home turns. Military supply trains pressed for paths the same hour coal and steel demanded priority. Every decision robbed some other essential flow. Even a partial reopening needed coordinated signaling to be safe. With interlockings down, each movement required a chain of men, hand flags, and written orders across ground still seeded with duds. The risk of side swipes and run-through points rose with every improvisation. By late afternoon, daylight assessment concluded what crews on the ground already knew. No classification would resume before nightfall, and likely not then. Night brought no relief. The second phase of the operation returned after dark and erased the day's tentative progress. Fresh craters overlapped fills that had not yet settled. New fires reopened cable ducts that had cooled to